So, slope fields. Find the slope of the tangent line to a circle centered at the origin with radius 5. That's a lot of words there. Slope of the tangent line. What does that mean? Derivative. So f prime or dy dx, either one. To a circle centered at the origin with radius 5. Do you remember how to write the equation of a circle? Centered at the origin, that makes things a little easier.
It's something squared.
Something squared and something else squared. That's not entirely wrong. X squared plus y squared equals r squared. So that's the center, or excuse me, that's a circle centered at the origin, radius 5. We want to find dy dx. So let's take the derivative of everything. So the derivative of x squared is 2x. What's the derivative of y squared?
2y dy dx.
Good. 2y, and don't forget the dy dx. 2y dy dx. And the derivative of 25 would just be 0. Okay, and the point of this was to find dy dx. So there it is. Let's move some things around to solve for dy dx. 2y dy dx equals negative 2x. If I divide both sides by 2y, I get negative x over y. So that tells me, let's write out what it tells me. It tells me the slope at any xy, at any point on the circle. Tells me the slope at any, that's the slope of any point on the circle. Okay, so that should be reviewed. That's not really slope field. That's just take a derivative. Implicit is the name of the type of differentiation if there's a y sort of buried in the equation. But it's not important that you know what it's called. It's important that you know how to do it. Would the equation be different for a circle centered at the origin, so x squared plus y squared, with a different radius? Basically, what effect did the 25 have on our derivative? None. So something maybe kind of weird is going on here. The answer is no. Because the derivative of 25 is 0. So whatever number was out there is going to go away, whether the radius is 5 or 10 or 100. Because derivatives of constants go away. Okay, here's where the slope field comes in. On a grid of points, so that's what we've got over here, we're going to draw short line segments. Slope pieces, what we could call them. So we're not going to draw big long lines. We're going to just draw pieces of a slope through each point with the slope negative x over y, and this will create a slope field. So first one, we'll walk through this one together. Construct a slope field negative x over y for the graph on the right. So let's just start over here at I don't know, it doesn't matter where we start really. I guess it's probably easier to start where we're all positive. So let's start at 2, 2. At 2, 2, dy dx equals negative 2 over 2, negative 1. So at the point 2, 2, there was an extra one, and I put it on your desk because it was close to your desk, but I bet it's Ty's. Problem solved. All right, so we're going to go to the point 2, 2, and we're going to draw a slope piece that's negative 1. So we're going to draw a slope of negative 1, which you can kind of look ahead, and even though those look more complicated, it's just a little piece with slope negative 1. So again, don't draw a full line there. It's just a little piece of a slope. Let's go 2, 1 here. At 2, 1, dy dx. So 2, 1, x is 2, y is 1. That would be negative 2. So steeper than the last one. And you're kind of just eyeballing where the other point would be so that you know what a slope of negative 2 would look like. All right, 2, 0, dy dx, is negative x is 2, y is 0. What's 2 divided by 0? Undefined. You can't do 2 divided by 0. So it's undefined. I can't put a slope there that's undefined. So that one's going to have to just stay blank. There's not a slope there. That's the official answer. The unofficial answer is, what does an undefined slope look like? Do you remember? Yeah, so it's probably an up and down spot, but we don't know that for sure. So all vertical slopes are undefined, but not all undefined slopes are vertical. So all we know is that it's undefined, so we better leave it blank. Let's go at 1, 2. So x is 1, y is 2, so negative 1/2. Again, it's helpful if you have more points out there, because you can sort of eyeball what a slope of negative 1/2 would look like, down 1 over 2. So you're sort of aiming for that down 1 over 2 point. You're not going to go all of that way, but at least that gives you some idea what the slope should look like. Okay, at 1, 1, dy dx is negative 1 over 1. So that's another negative 1 spot. Negative 1s are usually easy because to aim at the down 1 over 1 spot is pretty close. So there's my negative 1 slope. Let's see, where do we want to go next? I guess let's keep working our way toward the left here. So let's do at 0, 2. So negative 0 over 2. 2 over 0 was undefined. 0 over 2, 0. We still have plenty of pre-cal students who don't know that. Hopefully none of you are in that category. And you know what? While we're there, if x is 0, it doesn't really matter what y is. If x is 0, what's the slope? 0. So I'm going to, all my x equals 0s, I'm going to put a slope of 0 there. Except for the origin, because that would have 0 in the bottom, and can't do that. All right, let's do 1 on this other side here. So negative 1, 2. So negative, careful with the negatives, negative 1 over 2, it would be a positive 1/2. So again, kind of aim at the spot that would be up 1 over 2. Alright, I'm going to press pause and let you finish it off there. So for each point, do negative x over y, and then plot the little slope piece. Started with a circle, and it's like our slope field is sort of outlining a circle. We don't really know what the radius is of the circle. So our general solution is a circle. Our specific solution, we can't tell from the slope field, but that radius 5 would tell us exactly which circle we're working with. Number 2, consider these slope fields. Okay, so this is like all given. It's just more about looking at it. One of the big differences to tell, or to when it comes to matching, is to look at what it depends on. So this first one depends only on x. Another way to say that would be it doesn't change with y. It depends only on x, it doesn't change with y. So you look at the slope pieces, and any y column you look at, all the slopes are the same. Right? They change left to right because it depends on x, but it does not change up and down because it doesn't depend on y. So no change up and down, only change left and right. As opposed to the second one, it depends on y but not on x. So it's like it's all the same things except reversed. Depends only on y. No change in the x direction. So you look at any x row, pick any row you want, and there's no change because it doesn't depend on x. If you look up and down, it's changing, but it's supposed to change as you move up and down. It changes with y. That's one way to tell the difference between the two of them. Some key spots to look at or to find when you're trying to match is to sort of ask yourself, where does dy dx equal 0? Because it's an easy spot to find on the graph, right? You know what a zero slope looks like. And it's usually an easy equation to solve. So this first one, when x is negative 2, dy dx would be 0. So we look over at x equals negative 2, and all the x equals negative 2 have a 0 slope. What about this one? Where does the slope equal 0? Y equals negative 1. So if you look at y equals negative 1, all those slopes are 0. So we're sort of building up to matching, because you don't always, it'd be kind of a pain to build a slope field with, what's that, 100 little slope pieces 4 times. So instead we do a lot of matching. Alright, the bottom two depend on x and on y. And you don't have to memorize many of these. In fact, I don't know that you need to memorize any of them other than the circle. Negative x over y makes a circle. So if you see a circle, you can kind of know that one. That's the circle. Now you can still do the 0 thing. dy dx equals 0 when x is 0. So yeah, sure enough, when x is 0, all those 0 slopes. The one on the right still depends on x and y. For this one, you would probably just pick some points. Sort of the when in doubt, if you can't figure it out, pick some points and see what the slope looks like. So just pick some random point, 1, 2. The slope would be 3 because we're just adding them together. 1, 2. I don't know that that's 3, but it's pretty steep. Maybe pick something in a different quadrant. -3, 4. That slope would be +1, because all you're doing is adding them together. So at -3, 4, -3, 4, there's our +1 slope. Basically, do a few to match to make sure it's working. You can still do the 0 thing here. Y prime equals 0 if, it's a little bit weird, if y equals -x. And that's a little bit harder to see, but yeah, when y equals -x, there's a 0 slope. One way we use these, in the above slope field, sketch the solution curve going through the point 0, -3. So let's find the point 0, -3. That'd be right there. Here's sort of how to sketch in a solution curve. Basically, run parallel to the nearest slope, and definitely don't cross any slopes. This takes some practice. Once you get used to it, you kind of just go with the feel. That's the point of the field. Now, I'm kind of cheating because I know that means this is a circle with radius 3. So that makes it easy for me to sketch in my general solution, or my specific solution, my particular solution. Let's try it on the section. In the above slope field, sketch the solution curve going through the point 4, 3. 4, 1, 2, 3. And this one's a little harder because it's not a circle. So I have my first slope. I'm just gradually turning the corner here. Completely turns the corner. We get a 0 slope right in there somewhere. And then I can't cross this, what looks like a line right there. That sort of becomes an asymptote. Not sort of, it is going to be an asymptote. Because I can't cross it. Get closer and closer, but don't cross it. Then extended back the other way, it looks like the slope just gets steeper and steeper from there. 4, 3 starting point. Then do another one through -1, -3. I'm going to pick a different color. -1, -3. Start right there. So headed up, bending a little bit toward the left, and I'm about to approach that diagonal, but I can't cross it. So I think that's another asymptote. Bit of a side note on this one. That's the first one we've seen that is not separable. So we would not be able to separate and integrate that one. When you get to college and you take differential equations, then maybe you figure out something how to do with that, but not for us. So we couldn't solve it if we wanted to, so we just have to draw the slope field and go with that. All the other ones we could solve. In fact, so much going on, I never know what order to do it in, but back on this first one, if the slope is x plus 2, and we integrated that, so we went backwards from the slope, we could integrate this one. This is the easiest one to integrate. What's the antiderivative of x plus 2? What's the antiderivative of x? One at a time. X squared over 2 plus 2x plus some c. So that would be some sort of parabola. And you look at the slope field, and I think you can see that it traces out a parabola. So we get to the point where we can handle slope fields. We can also handle them where we antiderivative them and compare our answers. That's a little bit further down the road, though. All right, tips for reading slope field. Kind of mentioned some of these already. Look at the slopes along the axis. That would mean when x equals 0 and or y equals 0. Just because that makes the math easy, right? If you plug in 0 for one of them, it usually is an easy thing to figure out what the slope is. We talked about looking to see what the slope depends on. Is it x only? Is it y only? Is it both? I mean, more importantly, if it only depends on x, that's a good hint as to which one it is. If it only depends on y, that's another one. Positive and negative, so think about signs. Where is it a positive slope versus a negative slope? And then lastly, this is a rarely situation. Units on the slope fields may be different, meaning the scale markers might not always be 1, so be careful what you're looking at when you have one of those. All right, let's try to match these up, especially these. These look really similar, these 4, right? Because they all depend on x and y, so that doesn't really help.
I know what D is.
You know what D is. How do you know what D is?
Circle.
That's the circle. I mean, it's a circle by looking at it. Which one was the circle? The last one. Okay, so good. There's one out of the way. Now the rest of them. I wonder if we should just start at the top or start with the one that's a positive version of the one we found. So the only difference between the second one and the fourth one is that sign. So let's see if we can find this one, the second one. What would make it 0? Y prime equals 0 when x is 0. So when x is 0, we want y prime to be 0. Oh, I think that narrowed it down. I want when x is 0, I need the slope to be 0. Can you pick out which of the remaining 3 that's true for? B, those look like they're getting steeper. A looks like it has little lines going across there. So I think it's A. We could check a point. Let's be careful because I'm looking at the other ones. If I check 1, 1, that's going to give me the same slope as this other one. So let's check 1, 2, or maybe 1, 3. At 1, 3, slope equals 1/3. So I think it's graph A, but let's look and see at 1, 3. It's really hard to see what's going on here, but I think I'd believe that that's 1/3. I mean, I can't tell for sure, but it's positive and it's less than 1. So I'm feeling pretty good about A. Why don't you see if you can figure out the other two, which one is which? So we've got A and D right there. So BACD for the first one. Number 2, if you plug in x equals 0, the slope needs to equal 1, and B is the only one that does that. All right, now you try number 3. See if you can. What does it depend on? Check the x equals 0 or y equals 0 or where the slope is 0, and see if you can match them up. And I'm going to number these 1, 2, 3, 4 so that we can talk about them in a moment. Figure out which one is which. I didn't record any of that. Hopefully if you're watching at home you can remember how to match them up and things to use to match them up. So matching's pretty easy, or at least once you get the hang of it. Doing them is pretty easy. This last one is an example of a free response question. Probably not quite all of one yet, but pretty close to it. Consider this differential equation. Sketch the slope field on the 9 indicated points. So let's see. We've avoided the 0 in the denominator issue of is that undefined or is it vertical? Who knows? It doesn't matter for this one. So I'm not going to press pause, and you're going to. So point by point until you start to figure something out. Maybe you hit some shortcuts, like when y is 2, the slope is 0, so that's an easy one. I did most of them by hand. I got to the end and realized what was going on. That last one was just negative 1/3. I didn't show my work for that one. So as you get better at these, you kind of show less and less. I guess that's always true. And again, they almost always make some kind of pattern. So if one of them looks out of place, then go back and check that one because it's probably wrong. So those usually kind of check themselves on, at least if you're on the right track or not. Part B. Let y equals f of x be the particular solution to the differential equation with the initial condition f of 3 equals 1. Write an equation for the tangent line to the graph at x equals 3. All right, let's pause there, then we'll finish the rest of this. So tangent line means I need a point and a slope. I feel like we haven't done this in a while. Write the equation of a tangent line. What point will I use? What point should I use? 3, 1. It tells me x equals 3, y equals 1. So my point is 3, 1. My slope, how do I know what the slope of the tangent line is? Plug it in. They told me the slope. The very first thing they told me was dy dx is 2 minus y over x. So at 3, 1, so 2 minus 1 over 3 is 1/3. So my equation is y minus 1 equals 1/3 x minus 3. So there's part of my answer. The first question that it asked. Use the equation we just wrote to approximate the value of f of 3.5. So I'm going to plug in 3.5, not into f because I don't have f, but I have a tangent line which should be close to f. In fact, at the point 1, 3, it didn't ask us to do this, so I don't know if it would be wise to do this or not. The point 3, 1. So there's the equation we just wrote. And I don't know what this graph looks like, but it says use that line to just basically guess what the function is. So what should I do with my 3.5? Where am I plugging it in? If I want to find where 3.5 is on this line, let's plug it into this using that equation. Y minus 1 equals 1/3. 3.5 minus 3. I haven't solved for y, so it's not safe stop yet. 1/3. 3.5 minus 3. Oops, pardon that parentheses there. Plus 1. That's my approximation for 3.5. F of 3.5. If we followed that tangent line, this would be the value of f of 3.5. And that's an acceptable safe stop. 0.5 over 3 plus 1. Then it's, what is that, 1/6 plus 1. I'm just extending it further because I want to like visually see if that makes sense. 1/6 plus 1. Yeah, I was at 1, and now I'm at 1/6 more than 1. So I believe that answer. Seems reasonable. All right, last part. Find the particular solution. So this goes back to what we were doing the previous 3 days. dy dx equals 2 minus y over x. So this is the separate and integrate and then specificate, or however you want to say, use that initial condition. Precisionate. dy over 2 minus y equals dx over x. Kind of wish we'd picked a better one, or an easier one. Right-hand side. Right-hand side should be easy. What's the antiderivative of 1 over x? Natural log. And we usually put the plus c on the natural log side. Or the x side, excuse me. What about the other side? Antiderivative of 1 over 2 minus y? So you can kind of go the long way around if you need to. U is 2 minus y. So du is negative dy, negative natural log 2 minus y. Again, plus c, but not really, because we got the plus c on the other side. That's why I don't like this one, because I don't mind 1 natural logs. 2 natural logs? Come on, that's not very nice. So I want to go e to both sides, but not yet, because I don't like that. Like, I'm trying to solve for y, so I'd like to get rid of that negative. So that's easy enough, I guess. Multiply through by negative. That changes the c, kind of not. We don't know what c is yet, so it doesn't really matter. I guess let's do the e to this stuff. It's going to be ugly, but So the right hand side's easy. 2 minus y. The left hand side, because of that plus c in there, I can't well, let's see. We could still do that trick because I could make this c e to the negative natural log of the absolute value of x. Yeah, that's the same trick. E and natural log kind of cancel each other out, but don't like the negative there. E to the natural log of I don't like this problem. It's just ugly. So e to the natural log cancels each other out. C times 1 over the absolute value of x. At some point we need to solve for c, but we also need to solve for y. Take your pick. You want to solve for y first, or you want to solve for c first?
C.
C it is. So at 3, 1, 2 minus 1 equals c times 1 over absolute value of 3. So 1 equals c over 3. C equals 3. 2 minus y equals 3 over absolute value of x. Now I can solve for y. Move the y over, move the 3 over x stuff over. Man, that's a terrible answer. That's the correct answer. You're not going to get one that bad on a solving problem. Alright, the assignment today, or tomorrow, or whenever, worksheet 2. Here's how I suggest you break it up. You break it up however you want. I say today is 1 through 15, and tomorrow is the rest of them, 16 through 22. But you do them however you would like to do them. And number 1 is nearly identical to the one we just did. Yeah, really close to the one we just did. Then there's some matching, some drawing. Yeah, number 1's the same. You know what? Let's try number 5. Turn to number 5. You try number 5, then I'll do number 5, and then that'll. So there's the slope field. That's not too hard. Just slowly go through point by point. Although there was one little bit of a shortcut. When y is 0, the slope is 0. So that cut out a few of the point by point things. So just plug them all in. It does make some kind of pattern. Part B, show that. So that's the tricky part. What can you conclude about concavity? That's kind of the easy part. So for finding that second derivative, I need a derivative of the first derivative. That's going to be quotient rule. So I set that up, see if you can go from there. Again, quotient rule, gf prime minus fg prime over g squared, all the algebra. How are you going to find the particular solution given that condition? Separate, integrate, precisionate. Separate, integrate, precisionate. Separate, integrate, precisionate. Lots of calculus, lots of algebra. Tomorrow I'll do a few together. You'll work some together. Hopefully you finish before you leave tomorrow, and then you don't have to worry about anything over the break. Frozen screen. There we go.